Okay, so let's look at number 15, the last problem. It says, in this model, the predator population is modeled by the function. So we're talking about predator prey. And it is 800 times the cosine of 3t plus 7,000, where t is measured in years. So what is the maximum population? So if we were to see this on a graph, we could calculate what the maximum would be, or we could just interpret the actual parent function of cosine. So the cosine of t, otherwise the cosine of x, parent function wise would look like this. Let's draw one period of cosine. It goes from positive 1 to a negative 1, and it's from 0 all the way to 2 pi. So right now, if I asked you what is the max, you would say it's 1. That's as high as the graph goes. So just like we've been doing with all these other problems, we've been looking at A, B, C, D letters as far as transformations of the parent function. And we know that the A on this particular problem is 800. B would be 3, C is 0 because you don't see any adding or subtracting going on with that T inside the parentheses, and 7,000 is the shift going up. So if I wanted to know the max, I'm going to look at it like a transformation, if you will. Okay? So we could say that there's no shift going left or right. Okay, so it looks something like this. 800 cosine of 3t minus 0. Here's that cosine. And then plus 7,000 there at the end. So if I looked at it PEMDAS order-wise, and I started from the variable, I can see that there's no shift going left or right. Then I can see that there's a horizontal compression by 1/3. It looks like a stretch, but again, everything with the x, we're going to do the opposite. So all the graph did is, instead of looking like this, it was horizontally compressed by 1/3. So you could say it was, in a sense, squeezed by 1/3. Okay? Then we're going to look at this 800 multiplication. That is the amplitude. That means this will shoot up 8,000 or 800, and this will shoot down 800. So now my original one that used to go from -1 to 1 will now go from an 800 to a -800. That is what the graph will now look like. And then last but not least, we are going to shift 7,000 units upward. So if I move this, basically the entire graph, 7,000 upward, it's going to have a 7,800 point way up here. And if I went up 7,000, it would have a positive 6,200. So you're at a -800 that got shifted upward 7,000. So you see that, of course, it did this 800 to get up to 0. So we're basically going to subtract 800 from 7,000. And this is how we get the positive 6,200 as far as being like way over here. So 6,200 all the way up to the 7,800. Okay, and if you see the amplitude was 800 over here, and if I'm looking at a graph and I measure like 2 amplitudes, that 800 will become 1,600. So you can notice that there's still a 1,600 gap between the 62 and the 78. There's still a gap of 1,600. So it's another way to verify that your values are correct. So if looking at this like a cosine wave with transformations, you could see that the maximum, as far as what this graph would produce, would in fact be 7,800 as far as the answer goes. And let's see, what is the maximum? 7,800. And then find the length of time between successive periods of maximum population. Please round the answer to 3 decimals. So the calculator would in fact be needed here. All we're trying to find is between 2 maximums, what is is the length of time? We're trying to find what is the period that it would take to go between this maximum and this maximum. X-wise or T-wise, however you want to look at it, we're going to look at how long would it take. Okay? So, if this is the period, the new period if you will, it will be 2 pi over b is equal to our new period. And over here, when we were looking at this, we got b is in fact 3. So it could be 2 pi over 3. You could write it like this. 2 pi over 3 years. But because they want it to be in decimal form, we're just going to use the calculator real quick to find what is 2 pi over 3 equal. So control divide 2 times pi over 3, and we will control answer, and it's about a 2.094 since we're rounding to 3 decimal places. So 2.094 years would be the answer on that. Again, for the time in between, we're going to look at the period. That's it.